Oh, I was on full screen. Here we go. So in today's video, we learned how to divide mixed numbers with mixed numbers. And then for the homework, they set up a lot of weird situations that don't really make sense in the real world. I don't know that we would ever need to do this, but they're trying to make real world applications of what we learned in class today. The first of which, this is set up different in the workbook. So in the workbook, the very first one, A, how much longer is segment A than segment B? Um, whoops, is this, no, everything's kind of jumping around on me. Here we go. How much longer is segment A than segment B is a subtraction problem. And so you would take segment A minus segment B. Then B says segment B is how many times longer than segment B, A. So when you do this, how many times longer, you're looking at then segment B divided by segment A. And so I set up 3/4 divided by 1 and 1/4. C says segment A is how many times longer than segment B. And again, this doesn't look like it does in the workbook, but here I've got segment A is 1 and 1/4 divided by, because it's asking me how many times, English and math kind of match up. But then it says what fraction of D was A and C. Here it says what fraction of segment A is segment C, in which case it's backwards. You've got to take C divided by A, and then lastly, what fraction of, oops, I broke it apart. They should get together. Oh well. There it goes. Those should go together. And so then I go on to the next one, and it says Deandra's teacher challenged the class to bike 4.5 miles each day. On Monday, DeAndre biked 6 miles. And so to set this one up, how many times the daily goal did DeAndre ride? You're going to do 6 divided by 4.5. And you can't just divide like that. You need to first turn them into fractions. And so I've got 6/1 divided by, and then 2 times 4 is 8, plus 1 is 9. 4.5 is the same as 9/2. 2 goes into 9 4 times, there'd be 1 left over. And so there's a few ways to do this. The first of which is to just find common denominators. And so between 6/1 and 9/2, it would be 12/2 is the same as 6/1 divided by 9/2 equals 12/9. I can divide by 3/3 and I get 4/3. Another way to do this problem is to KFC, or keep the first, so 6/1, flip the second, 2/9, change the sign to multiply. At this point, 6 and 9 work really well together. I divide by 3, I get 2. I divide by 3, I get 3. And so I just multiply straight across. I get 4/3, or once again, 1 and 1/3. I could put it either way. So in here, I can do 4/3, and the computer should understand exactly what that means. On Tuesday, they only biked 1 4/5. Again, it's going to be 1 4/5 divided by 4.5. First thing, you got to change these into fractions. 5 times 1 is 5, plus 4 is 9/5. We already know that this one is divided by 9/2. Now, it looks like you can divide straight across 9 divided by 9 and 5 divided by 2, but 5 divided by 2 ends up on the bottom. It would have been 1/5. It's going to work out nice, but you could have gotten common denominators, which would have been 10. So this would have been 18/10. divided by 45 over 10, and that would have been 18 over 45. 9 goes into both of those. I don't know what's up with my voice to go. 9 goes into that twice, 9 goes into that 5 times. I get that the answer is 2/5, and 1 over 5 halves is sure enough 2/5. I could have also done KFC. I keep the first, or take a look at the right hand side, flip it over, then you multiply. 9 cancels with a 9, and 2/5 just ends up being 2/5. And so over here, I can just type 2/5 or any sort of equivalent of that. Submit. Now, normally, if you're given fractions, you want to do it in fractions, and then it's in a problem coming up with the rulers. I don't like doing that as a fraction. But a security guard works 9.5-hour long shifts. Ooh, that's a lot. At one point during the shift, the guard looks at the clock and realizes it's been 3 3/4 hours since the shift started. So in this one, you've got 3 3/4 divided by 9.5. 4 times 3 is 12, plus 3 is, that's 15/4 divided by 18, 19 halves. I can get common denominators. I would get 15/4 divided by 38/4. You would never do this kind of problem. It's just, unless you're really bored because you have a 9.5-hour shift as a security guard. But 15 over 38, that is not pretty. Take a look at the right hand side, flip it over, then you multiply. It would have been 15/4 times 2/19. Oh, it does simplify a little bit. No, it won't. This is 2, this is 1. I get 15 over 38. Not nice. If you're dealing with 38ths in a problem, you're doing too much math. Here we go. So, oh, yes, submit and explain. Oh, man, I have to go back to my keyboard. See work on the left. Now, you only have to do these problems one way. I'm showing it multiple ways just in case. Now, this is one where I would never, ever do this as a fraction. 2 27/50. It's so much easier to do it as a decimal. 2.54 centimeters to an inch equals 1 inch. And then you're just going to multiply the decimals out. But for today, they want us to use fractions. You would never do this problem as a fraction. It's just ugly. I've got 3 times, 2 27/50. Ugly. And so this is a multiplication problem, the first one anyways. I've got 3 over 1 times 50 times 2 is 100, 27. 127/50. 3 doesn't go into 50. It's just not going to work out nice. I end up getting, 381/50. Not nice. That's 7 31/50. You would never do that problem as a fraction. You would get 7.62 as a decimal. 7.62. Submit. I would use decimals, not fractions, for this one. I would. I'm going to see if it gives me credit. If not, I've got to go back and put it as a fraction. Same with this one here. What fraction of 1 inch is 1 centimeter? And so you're going to do, it's so much easier to just do 1 divided by 2.54, like on a calculator, even long division would be easier. But here I've got 1 divided by 2 and 27/50ths. 1 over 1 divided by 127/50ths is 50 over 127. Because I'm going to take a look at the right hand side, flip it over, then multiply. But 50 over 127, again, so ugly, so ugly. Divide 1 by 2.54. I've never done that calculation. So on a calculator, if I do 1 divided by 2.54, I get something ugly. I've never done that calculation. 0.39 with a lot of other numbers. But there we go. Submit. Okay, so let's keep going. Here we another one of these. If they're doing 10 divided by 2 and 27/50ths, they're asking how many inches are there in 10 centimeters. That's what they're asking. Question mark. That's good. Okay, number 9. There are 4 points plotted. Okay, good. Review. Where is this one? Well, this is different than the workbook. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 1, 2, 3 would be 25% or 1/4. Oh, it's percent. It's 25%. B would be 50%. D in this one is 10/12. 10/12 is like 86%. 5/6 is like, I don't know, 87 something percent. It's C. Point C is going to be the 66 2/3. It's also the same as 8/12 is the same as, why can't I do that math all of a sudden? I divide by 4, I get 2/3. Okay. Number 10, a nice quick review. 2/3 times 9 over 20. I can divide by 2 over 2, I get 1/10. Divide by 3 over 3, I get 1/3, or 1 and 3. I'm going to get 3/10. That bottom one, 1 and 2/5 times 3/14, 5 7/5 times, oops, don't flip. That's 3/14. 7 and 14 work well together. That's a 1 and a 2. I get 3/10 again. And so I got 3/10 and 3/10. And let's get that typed in and see how I did on these ones. See if I have to go back and change those decimals to fractions. Next. Completed, correct. We're good. And so that's all for today. If you have any questions, ask in class. Otherwise, I'll see you in the next video.